Hello, this is Mrs. Garple, and in this video we are going to work on inverses of functions. To begin, we're going to start by looking at a table. The thing that you need to remember about inverses is that what is originally an input for one function and an output for the same function switches so that the original input will become the output and the original output will become the input. So when you're having to write a new table for a function that's given to you as a table, we're going to use the inverse function notation, so inverse f of x, and my x column, which is my inputs, I'm going to enter what were my original outputs, so -6, -5, -4, -3, -2. And then their corresponding outputs is what their corresponding inputs were before. So -6 went with -1, -5 with 0, -4 with 1, -3 with 2, and -2 with 3. Keep in mind, this same thing will be done with ordered pairs. So if you're given a list of ordered pairs and you're asked to write the inverse of the function, all you're going to do is switch the x and y in every single ordered pair. So all the y values become x values, all of the x values become y values. Now we can take this to a graph just as well. If you want to find the inverse of a graph, it's going to reflect across the line y equals x, which is this dashed line. But more importantly, you don't even need to know what the inverse equation is. We're given the equation f of x equals 1/2 times x minus 3. What that tells me is I have a point at 3, 0, and I have a slope of 1/2 to get my next points. Well, to find my inverse graph, I just need to take these points and switch them around. So instead of 3, 0, I will have a point at 0, 3. Instead of a point at 7, 2, I will have a point at 2, 7. And when I graph my line, I will see that it also intersects where that line, the original function, intersected with the graph of y equals x. And here is my inverse function. Now I can write my equation of this from this graph. If I look at my slope, from 0, 3 to the next point, we're actually going up 2 and to the right 1, which means my slope of my inverse, and inverse notation looks like this. The slope of my inverse will be 2. Because my point is 0, 3, I can just say 2x plus 3. So while my original function gave me my x-intercept, my inverse function gives me my y-intercept. So what was the x-intercept of my original function has become the y-intercept of my inverse function. And we did this just because we switched the x and y values of some points to get our graph. I can also, especially if an equation is given to me in point-slope form, write the inverse function without having to rely on a graph to do it. So my inverse function for this particular equation, the original function is 3 times x minus 1 plus 2. My inverse is going to have a slope that is the reciprocal. So if we go back and we look at this graph, we have a slope of 1/2 and we have a slope of 2. Those values are reciprocals of one another. A reciprocal is when you can flip a fraction around. And when I flip 1 over 2, I get 2 over 1, which is the same thing as 2. So when I want the reciprocal of 3, I know it is going to be 1/3. Now the point that's given to me in my original function is 1, 2. So when I write my point-slope form, I need to use it in a reverse order. So x minus 2, and the 1 becomes the y value. So let's use this equation to graph our inverse function. We should have a point at 2, 1, and a slope of 1 to the right 3, up 1 to the right 3, and we can graph this line through these points. And you'll notice again that where the original function intersects the line y equals x, so does our inverse function. And you will see a line that looks as if we folded our graph along the dashed line of y equals x. Now, what if you don't have a graph and the function isn't in that point-slope form? And I'm going to make an adjustment to my notes here. There we go. You're going to start by replacing f of x with y. Everything else will stay the same for now. And then you're going to write the equation again, this time switching x and y. So it will become x equals x equals 2 times y plus 1 over 7. Notice everything else stayed the same. We only switched the x and the y around. Now we want to solve for y. That means we need to get y by itself, or isolate the y. The first thing I'm going to do is undo this divide by 7. The inverse of division is multiplication. So both sides will get multiplied by 7. We will now have 7x equals 2y plus 1 as our equation. We're going to do the inverse of plus 1, which is minus 1, on each side. Remember, what you do to one side of an equation, you have to do to the other. So we are left with 7x minus 1 equals 2y. It is not 6x because 7x and 1 are not like terms. And divide both sides by 2. And we now have, as our inverse, 7x minus 1 all over 2 equals 2. Now I could say y, but we're going to end up replacing that y with the inverse notation. So instead of saying 7x minus 1 equals y, I'm going to write 7x minus 1 over 2 equals the inverse of f of x. And that's how you find the inverse of any function. Start by replacing the function notation with y, switch your x and y, and solve for y. So let's take a look here. You'll notice that this one we are given a restricted domain, that x has to be greater than or equal to -3. And that's because the inverse of this function would not be a function if we were to graph the entire parabola. If I were to reflect this, I would end up with some x values having more than one y value. And if that's the case, you won't have a function. So I'm going to begin by writing this as y equals x plus 3 squared plus 1. And then I'm going to switch or swap the x and y. So it's going to be x equals y plus 3 squared plus 1. In order to take care of this y plus 3 squared, in order to undo that squared, I first have to do the inverse of plus 1. So I'm going to subtract 1. And we now have x minus 1 equals y plus 3 squared. The inverse of squaring something is to find its square root. So I'm going to take the square root of both sides, which gives us the square root of x minus 1 is equal to y plus 3. And finally, to isolate the y, I'm going to do the inverse of plus 3, which is minus 3. And I will have negative 3 plus the square root of x minus 1 equals, again, I'm going to use that inverse notation. So what does that graph look like? Well, let's use the graph we were given of the initial function to help us. We have a point at negative 3, 0. That means my inverse is going to have a point at 0, negative 3. We have a point at negative 2, 0, and that wasn't negative 3, 0 before. I made a mistake. That should be negative 3, negative 1, which is going to move my initial point 1 to the left. And then negative 2, 0, I have the y-intercept, 0, negative 2, and then we have negative 1, negative 3. So that's going to, not negative 3, but positive 3. It's above the x-axis. That's going to give us a point at 3, negative 1. And this is what our curve will look like. If we had the rest of our parabola, it would have been coming down below and we would not have had a function. So that's why we have a restricted domain. This one, we do not have a restricted domain, so whatever equation we get, we're going to graph the full function. And we are going to write y in place of f of x, just like I've done on the previous ones, equals 2 times the square root of x minus 1. Those parentheses initially were just to remind us that the entire difference of x minus 1 is underneath that square root. Next, switch the x and the y around, but keep everything else where it's at. So x equals 2 times the square root of y minus 1. Divide both sides by 2. And we have x over 2 equals the square root of y minus 1. Now the inverse of finding the square root is to square. So we're going to square both sides. And when you square a fraction, you multiply, or you square the numerator and you square the denominator. So that's how I'm going to get x squared over 4 equals y minus 1, and the inverse of subtracting 1 is to add 1. So now we have, and I'm going to write this so we can see it as a stretch of 1/4 x squared, because my inverse is a parabola, plus 1 equals, and then that inverse function notation, so the inverse of f of x, and we can graph this. Now, knowing what I know about vertex form of parabolas, I can tell you that I should have a point at 0, 1. And if I look at the graph I was given, I have a point at 1, 0. So that is, in fact, an inverse point. My next lattice point that I see on my original function is at 2, 2. Well, if I switch those around, that's also the point of my inverse. And then I have a point at 5, 4. So my inverse would be at 4, 5. And I have a point at 10, 6. So that's going to give me a point at 6, 10. So here is half of the parabola. Now remember, I said we don't have a restriction on the domain, so we're going to graph the entire parabola. And since I have one side, if I use symmetry, because we know parabolas are symmetric, I can find points for the other side of my graph. And I have my full parabola for my inverse function 1/4 x squared plus 1. And this concludes our video on inverse functions, graphing them and writing the inverse function.